I have a system of equations right here, and one way to, or another way to solve a system of equations is by graphing these equations. To graph them, I'm going to look for their x and y intercepts. So this first line, 2x plus 3y equals 6, well, I'm going to first substitute 0 in for x and solve for y on that first equation. And I get y equals 2. And the same equation, I'm going to let y equal to 0 and solve for x. So I have a point x equals 3 and y equals 2 as my intercepts, where they cross a particular axis at. So I can draw my coordinate pair, or my rectangular system. I know that y equals 2. I have a solution, and x equals 3. I have a solution. And if those are both accurate, then I know that I have a line that goes through those particular points. Well, let's do the same thing with that second line. 2x plus y equals 2. Let's set the first one, the x equal to 0. So y equals negative 2. And then 2x plus let the y equal to 0. And x equals negative 1. So I have another line that's at x equals negative 1, and then y is at negative 2. So there I was able to graph both lines, and at the point that the lines intersect, that value right there is my graphical solution. Now for me, sometimes it's kind of hard to tell exactly where it's at because I probably didn't spend enough time making my line straight and looking at it, but I have an idea roughly where it's at. It's over here at 2 or negative 2, negative 3, and up at maybe 4. But that's the ballpark where it's at. Again, if you spend a little bit more time in making the scale accurate, your solution is going to be a little bit more accurate.